Okay, today we're going to look at 8.1 Day 2, normal distributions and sampling distributions. Okay, so the law of large numbers says that if a random phenomenon with numerical outcomes is repeated many times, the mean of the observed outcomes approaches the expected value. The more variable an outcome, the more trials are needed to ensure that the mean approaches the expected value. So for example, you pay $1 to play a card game at the casino. If you select an ace, then you win $5. So let's organize that. The outcomes are you either pay $1, so if I pay $1, I'm losing that dollar, or I win $5. Okay, why does it say 4? Because I had to pay that dollar. So I paid the dollar. I'm technically only getting $4 back when I select an ace. So now let's look at the probabilities. There's 4 aces, so that means there's 48 not aces. So I'm going to lose the dollar 48 out of 52 times, and I'm going to win the $4 4 out of 52 times. What is the average winnings that you'll leave with? Well, that's a fancy way of saying what's the expected value. So we're going to take our -1 and multiply by 48, and our 4 and multiply by the 4, and that gives me -48 over 52 plus 16 over 52, which is -32 over 52. So if I divide that, I get -62. So, -0.62. So in the long run, after many games, we would expect to lose, on average, 62 cents each time we played the game. Okay, a sampling distribution tells us what value the statistic takes in repeated samples from the same population and how often it takes those values. This is described with a normal density curve. Okay, normal is capitalized, bolded, and underlined because we spent an entire chapter learning about normal density curves. So let me review the entire chapter in one slide here. Remember, we had the 68, 95, 99.7 rule. And if the normal distribution was 1 standard deviation below to 1 standard deviation above, I had 68% between and then 16% on either side. If we were 2 standard deviations above and below, there was 95% between and 2.5% on either side. And 3 standard deviations below was 99.7% in between and 0.15% on either side of the 3. Now, not everything fell 1, 2, or 3 standard deviations above or below average. So if it wasn't 1, we had to standardize. And remember the z-score formula? X minus the mean divided by the standard deviation. And then we use our table A. Now remember, this piece right here was my observation. So the X, hold on a second. Okay, the X was my observation. This was my mean. So let me write that down for y'all in case you're taking notes. This is your mean. And then this was your standard deviation. And this was your observation. And the Z was your z-score. And then I took the z-score to table A. Okay. For example, the test is repeated values taken on the same sample, your class. The test average was an 83 with a standard deviation of 5. So let's draw a quick picture. Okay, so if I look at my picture, well, those obviously, the average are 83, so I'm going to put 83 in the middle. Okay, so the 83 goes in the middle because that is my average. Standard deviation of 5 means I add and subtract 5, so 83 plus 5 is 88. 83 minus 5 is 78, so that's where these numbers come from. And then if I add 5 again, I get 93, and if I add 5 again, I get 98. If I subtract 5 again, I get 73. It looks like I need to fix this. I can subtract, that's 73, and this will be 68. I will fix that for your Google Slides. Okay, here we go. So what is the probability that a student scored above a 93%? So 93% greater than above is greater than or equal to. So I'm going to look at my thing over here. It's 93 to the right. So I'm going to look, 93 is 2 standard deviations above average. So I'm looking at the 2.5, right? This section over here is going to be in the 2.5 section. So my answer is going to be 2.5%. Number 2, what is the probability that a student scored less than 80%? Okay, so that's my keyword there, less than to the left. So I'm going over here. Okay, wait a minute. 80 is not one of my numbers here. So that means I have to standardize. So I'm going to use my z-score formula. I'm going to plug in 80 for the observed value minus the average of 83, divide by a standard deviation of 5, and that's going to give me negative 0.6. And then if I go look at table A, that table A value is going to be 0.2743. And that's going to give me 27.43%. So the probability that a student scored less than 80% is 27.43%. What's the probability that a student scored less than 88%? Okay, so if I look, 88% is one standard deviation above average, and less than is to the left. So I want to add together the 68 and the 16. So that's going to give me 84%. Okay, 8-2 day 2 practice problems is a Google Forms. I used these problems to ask multiple choice questions. Thanks, guys. Have a great day.